Hello everyone, welcome to this session on debugging pod failures in Kubernetes. If you've ever deployed an application to Kubernetes and noticed your pods failing, you know how frustrating it can be. In today's video, we'll walk through the process of determining why a pod fails using real-world techniques and tools provided by Kubernetes. Let's dive right in. Step 1. Inspect the pod status. The first step in debugging a pod failure is to inspect its status. Use the kubectl getPods command to view the status of your pods. Look for indicators like crash loop backoff, pending, or image pull backoff. For example, kubectl getPods -n namespace. The status gives you the initial clue about what's going wrong. For a deeper dive, use the command kubectl describe podname -n namespace. The describe command shows detailed information, including events related to scheduling, container readiness, and failures. Step 2. Check pod logs. The logs are a goldmine for debugging containerized applications. If a container in your pod fails, its logs often contain error messages or stack traces pointing to the issue. To view the logs of a container, use kubectl logs podname -n namespace. If your pod has multiple containers, specify the container name. kubectl logs podname -c container name -n namespace. Analyze these logs for errors, configuration issues, or any missing dependencies. Step 3. Investigate events. Kubernetes events provide a timeline of what's happening in your cluster, making them essential for debugging. To view events related to a pod, run kubectl describe podname -n namespace. Focus on lines under the events section. Common events include image pull failures, insufficient resources, or permission issues. Alternatively, you can get all cluster-wide events. Kubectl get events -n namespace events often highlight issues like image pull errors or node resource constraints. Step 4. Examine container termination. Reasons. When a container fails, Kubernetes provides a termination message explaining why. This message is stored in the pod status and can be retrieved using the kubectl describe or kubectl get commands. To view the termination reason, kubectl describe podname -n namespace. Look for lines mentioning exit code or reason. For example, an exit code of 1 typically means an application error, while 137 indicates the container was terminated due to an out-of-memory event. Step 5. Debugging with an interactive shell. Sometimes you may need to interact with a running pod to diagnose issues. You can open an interactive shell using kubectl exec -it podname -n namespace -bin sh. Use this to check logs, verify file paths, or run troubleshooting commands directly within the container. If the pod has already failed, consider creating a debug pod with a similar configuration using the kubectl run command. To summarize, debugging pod failures in Kubernetes involves a systematic approach. Inspect the pod status, analyze logs for errors, investigate Kubernetes events for context, check container termination reasons, use interactive shells or debug pods when necessary. By following these steps, you'll be equipped to resolve most issues with pods in Kubernetes. If you found this video helpful, don't forget to like, share, and subscribe for more Kubernetes tips and tutorials. Thanks for watching and happy debugging.